Hello and welcome to my third video about GNSS monitoring in T4D. In this video, I want to talk about post-processing monitoring. I want to show you the post-processing engine in T4D server, and I want to show you how to analyze the data in T4D web. In this, we also see how accurate the results are in my examples. In the Trimble Monitoring YouTube channel, you can also find the video about GNSS Monitoring 1, where I explain the connection in a GNSS receiver, and the video GNSS Monitoring 2, where I explain the RTK engine. Let's start with looking at my demo system. Here in this example, to show you the post-processing monitoring, I have 4 receivers configured, but one receiver, Hohenbrunn, is off since a while. So I have the receiver Haringstraße, which is used as a fixed station in this example, a closed receiver Saglerstraße, and a receiver Großhöhenrhein, which is around 70 kilometers away. Beneath each receiver, I have a storage module configured, and here I decided to store TCO2 data with the folder structure enhanced data rate of 1 Hertz, and to start the next observation file after 1 hour. To improve the results of my processing, I also added a ephemeris download module, which downloads predicted ephemeris from the University of Bern. I'll store this in a folder on my server, as well as the precise orbits. The precise orbits are available after 12 to 18 days, so at the moment I'm not using them in my processing, but I could if I want to use them in future. In the ephemeris manager, I've selected to use the predicted orbits and pointed them to the folder where I store all my ephemeris. These ephemeris are used in the post-processing engine to improve the results of the processing. In the post-processing, I have different modes at the beginning to select. I'm using a static mode, which is the default mode and normally used. This means, for example, for my post-processing engine with a 1 hour duration, I'll get 1 result for the hour. It's also possible to configure the post-processing engine in a kinematic mode. This would mean I'll get 1 result per processing interval. So in my result for 10 seconds, but it's normally not used to run all the time, because therefore you can also use the RTK engine. But the post-processing engine in kinematic mode can be used to analyze the data after something happened, like an earthquake. In the post-processing engine, you then have to select the folder structure, and the folder types, and you have to select the stations you want to process in the post-processing engine. You define a start time here. In the post-processing engine, it's also possible to stop the processing and changing the start time if you want to reprocess your files. Then in the 1 hour post-processing, I selected a session duration of 1 hour with a delay of 5 minutes. Here I could also use 1 minute, but it's important to select a little bit of a delay, especially with files which are compressed. It takes a while until the storage module is ready with the file and the post-processing engine can pick it up. I decided to use the standard values here. So I have an elevation cutoff of 10 degrees, a processing interval of 10 seconds, a maximum baseline length of 70 kilometers. I selected to use redundant baselines, and I'm not allowing float solutions. The post-processing engine can process very long baselines up to 200 or 300 kilometers, I did before. And there, sometimes the solution is not fixed, and you can define here to use a float solution. I'm not using any kind of filter here, as the filter delays the processing. So you could define a outlier filter which takes 3 epochs to calculate a outlier, to calculate a mean. And yeah, this delays the processing. So at the moment, I'm not using this. One more hint to the session delay. So I selected 5 minutes, but if you're using, for example, the final orbits from IGS, you can also delay the processing up to 4 weeks, which makes sure that the final orbits are available. And if you select this, the final orbits would be used in the post-processing engine. The post-processing engine has 3 views. Here in the first view, the status view, you see the next session, which will be processed and when the next processing is started. So in my example, in 20 minutes. And here you can see the results of the last processing. So with redundant baselines, I processed 3 baselines, the short baseline with 300 millimeter and the long baselines with around 70 kilometers. The status was always okay. The solution was fixed. The orbit solution is noted here with mixed, as for some satellites we used broadcast, as predicted ephemeris are not available. You can check this in the ephemeris manager predicted orbit. Here we can see that for some of the satellites, predicted orbits are not available, and so we use broadcast instead. Next to the orbits, we see the epochs, which are used, 360, and the delta northing easting height. In the history view, we can see the history of the baselines when they are processed, the session start and end time, the epochs, the lengths. And yeah, here we can see which file was found. So the post-processing engine calculates the baselines between the stations, and the integrity monitor performs a least square adjustment. Therefore, we have to select a fixed station, and I used the station Haringstraße on the top of our office. You can select here to exclude outliers, but I'm not using this, and I'm using the default values here for the alarming, as I'm using the alarming in T4D Web, which has more options. Here in the integrity monitor views in the map 2D, you see an overview of the processing or the area. In the current displacement, you see the current delta northing, delta easting, and delta heights, as well as the sigma values. And in the displacement chart, you can see the results of the processing here of the last month or the last 2 months. T4D Web has more advanced charting and analysis functionalities than T4D Server, so I'll show you the results of the post-processing engine in T4D Web. Therefore, I created 2 analyses. One which shows the results of my 1-hour post-processing engine, and one which shows the results of my 24-hour post-processing engine. Here I decided to have a normal chart with a rolling window of the last 60 days, and I decided to show log types. You will see this later. So here in the first analysis, I'm showing the receiver Saglerstraße and Großhöhenrhein with the component 2D and height. Let's look at the chart. Here we can see the results of the 2 stations in the component 2D and height, and I'll select only one to look at them in more details. So here we see the 2D displacements of the station Saglerstraße, where the baseline is only around 300 meter. And there we see that the variations are around 3 or 4 millimeters. In the height component, we have more variations. Here they are roughly below 1 centimeter. For the longer baselines, we have more variations. Here in the 2D, the variations are below around 2 centimeters, and for the height, they go up to 8 or 9 centimeters. Here we see the lock I mentioned before. The server was down for for a day, and so here I added this as a log type to the analysis to see why we have an outage here. Here we can see the results of the 24-hour sessions and the two baselines. So looking at each component, we see that the delta 2D and the short baseline has variations around 4 millimeters, and in the height component, we have only variations around 2 millimeters. In the long baseline, we have in the 2D component variations around 5 millimeter, and in the height component, we have variations around 1 centimeter or 2, with outlier here where we don't, where the server was down for a day and we have two files which are not completed, and so a lot of missing epochs. Thank you for watching this video and check out the other videos in our channel.